Hello, students and YouTube listeners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Communal College, California. This is the part 3 of my lecture on Design Example 3, Making Decisions Software. This part focuses on converting algorithm into source code. So we're going to show in the table form one of the key part of the algorithm, how to convert that into source code line by line. That kind of mapping is very important. If your algorithm is not accurate, it might result into a program that is inefficient, or it has bugs. Bugs means the program is not going to give you correct results. Computation may be wrong, or it might confuse user. It may not be user friendly. So key part of the algorithm that we showed in part 2 was this thing here, that a user enters a choice whether they compute hypotenuse or base or perpendicular. So they'll enter one of these characters, and if their choice is h or hypotenuse, then I've explained this algorithm to do that. And then if they choose base or perpendicular computation, then of course there are the other parts that you are supposed to fill out. So what I'm going to do in this video, show you take this algorithm for computing hypotenuse and show line by line how we can convert them into source code, these lines. So let me just go to a table where I'm doing that. Incidentally, in your submission of algorithm, you don't need to do this table. Please don't do it. I've done the table to explain to you line by line how algorithm can be converted into source code. You can do it for your own purpose on a scratch paper, but for grading purpose, I don't want to see it. It's more reading than I need to do. But for your own development, you can do anything you want. So let's go to the table. This table gives all the steps of algorithm, step 5. And one more time, people who are not listening, please listen. Do not do this table for me to read. You can do it for your own understanding, but do not put that into your IO document for lab 3 or any other lab for that purpose. So line 5 was that if choice is H, then this is the algorithm line, this is the source code line. So this part is same in source code and algorithm, but when you convert from algorithm to source code, the word then gets replaced by a left curly brace. So the way we are showing mapping in this table is that whatever is colored same, they map to the same. Okay, so then is not used in source code. Instead, it is replaced by a left curly brace. That could be on the same line or next line, doesn't matter. And as you know, that every left parenthesis or curly brace or square bracket or angular bracket always matches with the right one, which we'll show later. Okay. Line 5.1 was print input message, end of line. Input message was that enter in this case, two other dimensions, and you cannot enter 0 or negative. You should not enter 0 or negative. In your document, you can see what this was, but it basically gives some directions to input the data. Very important, and I have no idea why people don't get it even till the end of the semester. Print comma is replaced in the source code by cout arrow arrow. This does not go into algorithm. Cout and arrow arrow insertion operator does not go into algorithm. Okay, what is in the source code does not go into algorithm, except we do have some time that there are some common portions like this. Okay, so print comma is replaced by cout arrow arrow. Anytime you have comma in print statement, that would more than likely be replaced by arrow arrow. Input message same, because that's a string, and EOL, this comma gets replaced by this arrow arrow. EOL is end of line, ENDL, and of course in source code every statement except the signature lines require semicolon. You're not allowed to put semicolon in algorithm, and of course in source code except signature lines semicolon is required. So I'm taking a lot of pains here to explain what cannot go in algorithm. In source code, if you are missing something, compiler will flag you. But there's no compiler to correct your algorithm. That's a human effort. You have to do it. So be very clear what I'm saying here. Cout, arrow, arrow, semicolon, cin, this arrow, arrow, do not go into algorithm. They have no place for it. Okay. Line 5.3, 5.2, enter value of the base. And we are giving a format. Once again, print, comma, is replaced by cout arrow arrow. And then they're going to enter 5.3 on the keyboard, value of the base, and they'll press the enter key. This means that memory location base takes that data, stores in there. That translation is very simple. C in arrow arrow base. Okay. Line 5.4, echo print base means just output what they entered. It'll say cout, you entered base, ENDL, semicolon. And although to compute hypotenuse, negative value will get squared because we're going to multiply the value by itself. But there are situations that you may want to compute other geometrical properties, trigonometric properties like cosine, tangent, or sine. In that case, negative value will not be very useful unless you go into negative side of the x or y axis, which we are not assuming here. So we use abs function to drop. If this was negative, abs will remove the minus, store it back, and that code is same in algorithm and source code, except source code had the semicolon. Okay, 5.6. Then we need a value of perpendicular. And here my entry broke down into two lines. I don't know. Okay, but it should be in one line. Let me see if I can fix that. I may have to make it even smaller. Yeah. And then I do want to move to next line. Enter the value of the perpendicular, and that would translate into source code. Enter the value of perpendicular. Input into perpendicular perp, and that is seen perp. Echo print perp. See out, you have entered perp. And once again, casting to app using the absolute function to convert. Just take the absolute only, drop the minus sign. And that code is same in algorithm and source code, except source code has a semicolon. Now we do the second if, which is inside this if, nested or embedded, to be more precise, embedded inside it. We check in 5.10 if base is 0.0 or perpendicular is 0.0. If either is 0 or both are 0, then this whole Boolean condition is true. And in that case, we cannot do any computation. So once again, then got changed to left curly brace. And inside the scope of this if statement, we say computation with one or both sides with value 0.0 is not possible. Please rerun the program with realistic values. Here I allowed output to break, print statement to break in 2 lines. You could do that in algorithm, but in source code we cannot. So that's why I made sure that in source code, entire cout is on 1 line, like this. Okay. So hopefully by now it's very clear how to convert algorithm into source code. If your algorithm is inaccurate, your source code will be inaccurate, because there is one-to-one correspondence. And then we do need a right curly brace to match with this left. There's no corresponding thing in algorithm for that. Now, if this whole condition is false, then we execute the else block. And did I speak wrongly earlier that if this is false, we will do this? No. If I said that, I'm wrong. If either this is true or this is true or both are true, then this whole condition is true. You can use the truth table right now for OR operator to see when this composite condition will be true. And the result will be if either this is true or this is true or both are true, then the entire condition will be true. Okay. But if both conditions are false, then this Boolean condition is false. So then we go to the else block. And else block, again, in source code, we have the left curly brace. In algorithm, we don't. That's the other thing. You should not use curly braces in the algorithm. And so this line, else, translates in source code to else and left curly brace. Else does not have it then. Please don't do it. Don't put it then with else. It doesn't have it. If you have else if, then you have it, but with else alone you don't. So this computational expression is transferred as is, because we already have in C++ form in the analysis and with the semicolon. And this will compute the hypotenuse because we have made sure these are both non-zero values. And then we print or see out the value of hypotenuse. Okay. So and if is translated into right curly brace. So I've shown you a crucial part of algorithm, how that is written correctly, how that is step by step converted into source code correctly. The rest is very similar. There are two more blocks to compute base or hypotenuse. That's all shown in source code. So I'll just show you the source code now. We apply scientific so that all our output will be in scientific format. All numbers will have scientific format. This was the input message, const string. Notice IOStream, IMNF, CMath. And this is my mistake. I forgot to number include string. That has to be done. Otherwise, I'll get the compile error. I have no idea how that happened. This program was run, but somehow that got missed. Without this will be a compile error. So I just added that. Int main, and then rest. This source code we have already discussed. But if their choice is not hypotenuse computation, then we do this else if base computation, and then we execute this block where if both are 0, base cannot be computed, but hypotenuse has to be larger than perpendicular. If it is smaller, then also we cannot do computation. So only case where I can do base computation is that hypotenuse is larger than perpendicular and neither hypotenuse or perpendicular is 0. And then, of course, we use one of the expressions to compute base, and we output that. Notice, please do not use POW function to do square. It's much easier to just multiply the thing by itself. Making function calls is more complicated and it slows down your program. Do not use POW function to do straight, square, cube, even power 4, 5, or 6. It's not worth it. Okay. Now, last one is else if they want perpendicular computation. Then once again you take input for base and hypotenuse, and you do the same testing that both values should not be 0 and hypotenuse should not be less than the base, and only then we compute the perpendicular and output that. There is an else block that they may not have entered either P, B, or H, and we need to take care of that because keyboard has so many keys. So we take care of that by this else block that you made the invalid choice, and run the program again, and we say goodbye. This is the output from our test runs. You should actually type this program, source code, and confirm as a practice and otherwise that you match this test run. This is a very good practice in learning how to type programs that have nested if and else and embedded if and else. So that will really help you. I have 8 different test runs. Test runs make you test your program through whatever branch you are testing. You need enough number of tests that When all tests are done, then all code lines have been executed. That's the only way to reveal bug in any part of your program. Military will not buy any software from any company unless a proof has been shown that testing data ran, all lines of code have been executed. Okay? All right. So that's the part 3. And there will be discussion forum for this part as well. Post your questions there and we'll try to answer them, or one of your colleagues can answer them. Thank you for listening, and I'll see you soon in the next lecture.